In this video, I want to talk about matrices. Some of the items I want to cover are creating matrices, matrix operations, eigendecomposition, indexing, row and column names, and matrix augmentation. A matrix is a two-dimensional table with rows and columns of data where each element is one of the atomic types we previously discussed. If you open the R console and type help parentheses matrix, you'll see a window pop open showing the documentation you see on the screen now. If you look at the bottom of the screen under the section titled Usage, you'll see matrix parentheses data equals NA, so data is a parameter, NA is the default value, in row equals 1, so number of rows, in col equals 1, so number of columns, and by row equals false. This tells R to populate the matrix elements along the columns rather than the rows. Let's look at some examples. In the first example, I type matrix parentheses 1:4, in row equals 2, and in col equals 2. This is going to create a 2 by 2 matrix, 2 rows, 2 columns, and take the elements 1, 2, 3, 4 and lay them out along the columns. In the next example, I do a similar thing, except I specify by row equals capital T. So capital T is short for true in all caps. The only difference in this example is that it takes the elements 1, 2, 3, 4 and lays them out along the rows rather than along the columns. In the next example, I type matrix parentheses 1:6 and then in row equals 3. Here I didn't specify in col. So R is going to take the 6 elements and say, hey, I need 2 columns. So it's going to automatically create 2 columns so that each of the 6 elements are used. Since I didn't specify by row, it takes the default value false and lays the elements along the columns. In the next example, I type matrix parentheses 1:6, in row equals 2. Again, I didn't specify in col, so R takes the 6 elements and says, hey, I need 3 columns. So it creates 3 columns. I also didn't specify by row, so its default value is false, and it takes the 6 elements and lays them along the columns. In this example, I type matrix parentheses NA, in row equals 4 and col equals 4. So this is going to create a 4 by 4 matrix where every element is NA. Notice I didn't pass 16 elements, I only passed 1, so this also shows vector recycling occurred. In the next example, I type matrix parentheses 0, in row equals 4, in col equals 4, and then I specify an additional parameter, dim names, and I assign it the list containing 2 character vectors. The first character vector are the row names I want, and the second character vector are the column names I want. If we look at the output, we see a 4 by 4 matrix of zeros, and you can also see the row names and the column names. Let's look at some matrix operations. In the first line, I create the 2 by 2 matrix M containing elements 1, 2, 3, 4 laid out along the rows. In the next line, I type M plus M, which perform addition element-wise. So instead of 1, 2, 3, 4, we see 2, 4, 6, 8. In the next line, I typed M times M, which will perform multiplication element-wise. This is the same result as typing M squared. In the next line, I typed M to the mth power. So 1 to the first power, 2 to the second power, 3 to the third power, and 4 to the fourth power. Matrix multiplication, inverse, transpose, determinant, and eigendecomposition may be easily performed. Let's look at some examples below. In the first line, I typed M %, star, %, M, which means M times M, where the times means matrix multiplication. In the next line, I typed solve parentheses M, which means the matrix inverse of the matrix M. In the next line, I typed T parentheses M, which means the matrix transpose of the matrix M. In the next line, I typed eigen parentheses M, which performs eigendecomposition and returns a list of eigenvalues and their corresponding eigenvectors. Let's talk about indexing. An element of a matrix M can be accessed using square brackets containing its row index and its column index separated by a comma. Let's look at some examples. In the first example, I create a 3 by 3 matrix containing the integers 1 to 9 inclusively, laid out along the columns. I then type M square bracket 1, 1, which refers to the element in the first row and first column, which is the element 1. I then type M square bracket 2, 3, which refers to the element in the second row and third column, which is the element 8. I then type m square bracket 2 comma, which just refers to the second row of the matrix. I then type m square bracket comma 1, which refers to the first column of the matrix. Let's do some more examples. First, I create a 3 by 3 matrix M containing elements 1 through 9 inclusively, laid out along the columns. I then type m square bracket double vector 1, 2, comma, and this is going to grab rows 1 and 2 of the matrix. I then type m square bracket, comma, double vector 1, 3. This is going to return the columns 1 and 3 of the matrix. I then type m square bracket, logical vector true, false, true, comma. This is going to return the first and third rows of the matrix M. And in the last example, I type m square bracket, double vector 1, 3, comma, double vector 2, 3. This is going to grab the elements in positions 1, 2, 1, 3, 3, 2, and 3, 3. So it's a submatrix. Let's talk about modifying matrices. The assignment operator can be used to modify matrix elements. So first I create the 3 by 3 matrix M, and then if you note in the next line, I type m square bracket 1 comma 1 and I assign it the value 0. Then in the next line I type m square bracket comma 3 and assign it the value 0. So here I'm saying take the third column and assign all the element 0. So here's another example where vector recycling occurs. Then I just type m, press the return or enter key in the R console, and it outputs m after it's been modified. Let's talk about matrix dimensions and attributes. First, I create a 3 by 3 matrix M containing integers 1 to 9 inclusively, laid out along the columns. I then type attributes parentheses M, and as you can see, there is a dim attribute, and here dim refers to the dimension of the matrix, which is an integer vector 3, 3. The first 3 refers to the number of rows, and the second 3 refers to the number of columns. You can also just type dim parentheses M to get the integer vector. The next line confirms that dim parentheses M is in fact an integer vector. Since dim parentheses M is an integer vector, you can additionally type square bracket 1 to get the first element, which is just 3. Row and column names of a matrix can be set with the functions row names and column names respectively. First, I create a 4 by 4 matrix of zeros, and then I note that both row names parentheses M and column names parentheses M are null. I then assign both row names parentheses M and column names parentheses M character vectors. Notice that row names and column names are now attributes of the matrix M. Also, row names parentheses M and column names parentheses M are no longer null. They return the character vectors I specified. CBIND and RBIND augment a matrix with the column vector and row vector respectively. First, I create a 4 by 4 matrix of zeros and assign it to M. I then augment the matrix M with a column of 1s. I then augment the augmented matrix M with a row of 1s. I then type M and press the return key so that the elements of M are displayed. This concludes the content of this video. If you enjoy my videos, please subscribe. I hope to see you in the next video.